Okay, so question number one, we're doing questions 1 through 8 on page 33. And question number one asks, how many sides does a regular polygon have if each exterior angle measures 30 degrees? Well, you don't have to skip this question. You know that all polygons have exterior angles that add up to 360 degrees. Okay, all polygons' exterior angles equal up to 360 degrees. So if you take 360 degrees and divide by 30, it's going to give you 12. That means that your polygon is going to have 12 sides, 12 sides and 12 angles. Or really, I should say 12 angles and 12 sides, because the number of sides matches the number of angles. So 360 divided by 30 degrees gives you 12 angles, and 12 angles is going to give you 12 sides. So that's how you know how many sides it has. For example, take a triangle. Take a quadrilateral, which you know that these are all 90-degree angles. These are 90, these are 90, these are 90, and these are 90. Well, you know that these are linear pairs. So if I tell you that, listen, a polygon has an exterior angle of 90 degrees, how many sides does it have? Well, you know that all of the exterior angles come out to be 360 divided by 90. It's going to give you 4 sides and 4 angles. So we can see here that all you have to do is just take 30 and take 360 and divide it by 30, and it tells you how many sides you have. Question number 2. How many sides does a polygon have if the sum of the measures of the interior angles is 3,960? Well, now they're giving you the sum of the measures of the interior angles. Well, we know how to find it. We know that the formula for this is n minus 2 times 180 is equal to the number of degrees in a polygon. Okay? This is the formula. This is how we find how many degrees there are inside of a polygon. Except now, they're telling me the number of degrees. So I'm going to have n minus 2 times 180 is equal to 3960. And they're asking me to find n. Well, take a look here. We're multiplying two things here. It's kind of like saying, what's 5x equals to 10? Well, I'm multiplying these two things here. So what would I do? Well, naturally, I would divide both sides by 5, right? I would divide by 5. Well, notice that these two things are being multiplied here, right? So what am I going to divide by? Just divide by 180. And you're going to get n minus 2 is equal to 3,960 divided by 180. And that's going to give you 22. So I have n minus 2 is equal to 22. And then from that, well, it's pretty simple. We know what we do from there, right? Have n minus 2 is equal to 22. I'm going to add 2 to both sides. And n is equal to 24. So how many sides does it have? Well, it has 24 sides. And if you think about it, if I plug 24 into my formula here, well, 24 minus 2 times 180 should give me 3,960. 24 minus 2 is 22 times 180 gives me, look at that, that's how many degrees are inside. So just with a little algebra, we can solve this question right here. Question 3 says, if the sum of the measures of the interior angles of a polygon equals the sum of the measures of its exterior angles, how many sides does it have? Well, here all it's saying is that the degrees inside of the polygon equal the degrees on the outside of the polygon. Well, let me ask you a question. how many degrees are there on the outside of any polygon? Well, we know that any polygon has 360 degrees on the exterior, on the outside. And now they're telling us that the sum of the measures of the inside is equal to the sum of the measures of the what? On the outside. So I know that on the outside it has 360 degrees. So they're saying that, listen, this polygon also has the same amount inside. Well, let me ask you a question. What polygon do you know has 360 degrees on the inside? As a matter of fact, it's staring at you dead in the face. A quadrilateral. Because we know that a triangle has 180. We know that a pentagon has 540. And the only one that has 360 in it that we've talked about is a what? Is a quadrilateral. So this quadrilateral has 360 on the outside, and it also has 360 on the outside. So our answer is, it's a quadrilateral. And a quadrilateral can be a square, it can be a rectangle, or a quadrilateral of that sort. We're skipping number 4, and we're moving on to number 5. Number 5, they want to know what the measure of angle A is and what the measure of angle B is. But if you look at number 5, first thing we have to do is you have to count how many sides we have here. Well, we have 1, 2, 3, 4, and 5. So I have a pentagon. And the first thing I want to know is, well, how many degrees should a pentagon have? Well, for that, I use my formula, which says n minus 2 times 180 is equal to degrees inside a polygon. Okay? Well, I know I have 5 sides here. N represents the number of sides, so it's going to be 5 minus 2 times 180, which is 3 times 180. And I think that's 540. Let me just double check here. 180 times 3 is equal to 540. Yeah. So I have, which is 540 degrees. So a pentagon has 540 degrees. Well, I know that this here is 90. I know that this here is 116. I can find this angle here because I know that these two are a linear pair, which means that they add up to, these two together here add up to 180. So I could just do 180 minus 82. And that's going to give me 98. So I know that this is 98 degrees. And look at these external angles here. I know that these external angles here are all congruent. I know that they're all congruent. If these external angles here are all congruent, that means that the internal angles that they create are also going to be all congruent. Well, if I add these up together and subtract it from 540, I know how much I'm going to have to divvy up between these 3 angles. So let's take a look here. Let's add those all together. 98 plus 116 plus 90. 98 plus 116 plus 90 is equal to 304. So these angles here add up to 304. So 540 minus 304 is going to give me 236 degrees. So now I know that I have 236 degrees to divvy up between these angles here. So 236 divided by 3 is going to give me 78.7 degrees. So B is 78.7 degrees. And finally, A is pretty easy to find because I know that these are also a linear pair. And these two together should equal to 180. So all I have to do is just 180 minus 116, which is going to give me 64 degrees. Moving on to question number 6. Number 6, they want me to find the measure of angle B and the measure of angle A. And they give me no numbers. But that's okay. That's easy to do because here I have a regular triangle where all the angles and all the sides are congruent. Here I have a regular quadrilateral where all the angles are congruent. And here I have a pentagon where all the angles are congruent as well. And here I have an isosceles triangle down here. So I know how many degrees are inside of a triangle. I know that a triangle has 180 degrees. So if I take 180 and divide it by 3, I know that each one of these angles here is going to be equal to 60 degrees. I also know that here, this is a quadrilateral, and I know that a quadrilateral has 360 degrees. And if I divide that by 4, I'm going to get 90 degrees. So I know that this is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And I have a pentagon here. And if you forgot how to figure out the degrees inside a pentagon, just remember, just use n minus 2 times 180, where n represents the number of sides, 1, 2, 3, 4, and 5. So that's 5 minus 2 times 180, that's going to give me 540. And if I take 540 and divide it by 5, I believe that's going to give me 108 degrees. Let me double check that. 108 degrees, that is correct. I'm going to get 108 degrees. So this is 108, this is 108. Okay, so far so good. Now the easiest one to find is probably going to be A. If you notice here, I got like a little bit of a circle going on here. From here to here is 60, 90, 108. And we all should all know that in a circle, how many degrees are in a circle? Yes, there is 360 degrees in a circle. So if I had 60 and 90 and 108 and subtract it from 360, I should get A. So let's do that. Let's add those up together. Here we go. 60 plus 90 plus 108 gives me 258 minus 360, and that's going to be equal to 102. So I know that angle A is 102 degrees. 102 degrees. Next, I also have to find the measure of angle B. Now this one might be a little bit more difficult or a little bit more tricky to do, because here I have an isosceles triangle, and I hope you remember that in an isosceles triangle, the base angles are congruent. But I don't really have any information here that might help me out, or any information here that might help me out. But look a little closer, and right here, what do I have here? I kind of have like another circle going on from here to here, right? Well, again, this is 90 degrees. This is 108. And I can actually figure out how many degrees it is from here to here, because in a circle, there are 360 degrees. So I could just add these two together and subtract it from 360, which is pretty easy to see. 90 and 108 is going to give me 198. So that's 198 degrees. 198 degrees, which are these two together. And I'm going to subtract that from 360. 162 degrees. So this angle right here is 162. So from here to here, you can't see it. It's a very shallow spot, but from here to here, it's 162. 162 degrees. Because I know that if I add these two together and subtract from 360, I get 162. But we also know that in a triangle, how many degrees do we have? 180. So I've used up 162 degrees. So 180 minus 162 is going to give me, let's see here, 180 minus 162 is going to give me 18 degrees. So that's equal to 18 degrees that I have to divvy up for a little bit here and there. If that's 18 divided by 2. And 18 divided by 2, I hope we can all see that that's going to be equal to what? To 9. So 18 divided by 2 is 9. So this angle right here is going to be 9. And this little angle right here is going to be 9. Okay? Because I used up 162 degrees right here out of the 180, and I have 18 degrees left to divvy up between these two angles here. So B is also going to be 9. Let's take a look at question number 7. Well, the first thing I want to see is I want to figure out what kind of polygon do I have here? How many sides do I have? Well, I got 1, 2, 3, 4, 5, and 6. So I have 6 sides here. So the first thing I want to know is how many degrees should I have in total inside a 6-sided or a hexagon? A 6-sided polygon or a hexagon. So I'm going to use my formula, where n is the number of sides. So that's going to be 4 times 180, and I believe that's 720. Yep, 720 degrees. So I know that inside this polygon here, I should have a total of 720 degrees. And you can see how we're going to start the little puzzle question here, how we're going to figure out the missing parts, right? This is 82, this is 34, this is 72. Well, I know I can find this right here because these are a linear pair. So just subtract 72 minus 180. It's going to give me 180 minus 72 is 108. So this is 108 degrees there. So far, so good. What else? Now, these are a little bit harder to figure out because I don't know what these are. So now they're kind of forcing me to find out what these are as well, right? Don't know what this is. Let me see if I know any other exterior angles. Again, I don't know this one here, but can I find it out? Sure. I know that these are also a linear pair, which add up to 180. So all I have to do is 180 minus 134. That gives me 46. And I can also find this one here because these are also a linear pair. All I have to do is 180 minus 82. It's 98. And now, although I don't have all the information inside of my polygon, I do have all the information on the outside that I can solve for x. Because now I know that if I add up all these exterior angles, how much do they add up to? How many degrees are there on the exterior of any polygon? If you guess 360, then you guess correctly. So let's take a look here. So I know then that x plus 2x plus 3x plus 72 plus 46 plus 98 is equal to 360. So let's try that out. Okay, because on the exterior of any polygon, the angles all add up to 360 degrees. Now let's combine like terms. 1x plus 2x is 3x, 3x plus 3x is 6x. I'm going to add these three together. $288. Yeah, I think I made a mistake there. Did I? Let me double check my math. 72 plus 46 plus 98. Yep, it's 216. Made a mistake there. Yeah, this shouldn't be. Should be 72 plus 46 plus 98. Made a mistake there and added up my interior. So you got to be careful with that. There we go. These are all my exteriors. X plus 2x plus 3x plus 72 plus 46 plus 98 is equal to 360. So I still get 1x plus 2x, 3x is 6x. Let's add these two together, these numbers again. So 72 plus 46 plus 98 is equal to, it's 216. My mistake. So now, subtract 216 minus 216. So x is 24. So now we know that x is 24. Well, now we can start answering some of these questions here. But I know that this is going to be 24 degrees. I know that 2 times 24 is 48 degrees. And I know that 3 times 24 is 72. Because I'm multiplying times 24. X is 24. Now that I know what these are on the outside, now I can figure out A, B, and C. Well, I know that these are a linear pair. Well, you know what? Let's do this one first. This one seems a little bit easier. So I know that these are a linear pair. So 72 minus 180 will give me C. So this is going to be 108. I know that these are a linear pair. So 48 minus 180 is going to give me 132. And then 24 minus 180 is 156. And there I got all my angles. They made you test all your knowledge about what you knew about interior angles. Well, first, what you knew about exterior angles, what you knew about interior angles, and then plugging in for those angles. So they really wanted to test you here. They really wanted to test you. And if you got this question right, you really know what you're doing. Question number 8. We have a bigger image here like this. And again, they want us to solve for A, B, C, and D. If I can give you some advice like I've given you in the past, before I even start plugging in for A, B, C, and D, I would just start filling in as much information as I possibly can inside this image. I wouldn't even start going for these particular ones. I would just start filling in everything I knew. So let me do that. What kind of shape do I have here? Let me see. 1, 2, 3, 4, 5, 6, 7, 8. I got an octagon. So I can figure out how many degrees should be inside of an octagon using my formula, which is n minus 2 times 180. So that's 8 minus 2 times 180. So that's 6 times 180. And that's going to give me 1080. So inside an octagon, I should have 1080 degrees. And if I divide by 8, that tells me that every angle is 135 degrees. So I know that this is 135, 135, go all the way around. Oh, and look at that. In the process, what did I get? I got the measure of angle A, which is what? 135 degrees. Now, here I have an isosceles triangle, which means that these two base angles are congruent. But wait a minute, this is a straight line here, and I know that these two angles are a linear pair. So I can actually figure out this angle right here by subtracting 180 minus 135. That's 45 degrees. That means that this angle right here is 45 degrees. And since this is an isosceles triangle, these two base angles are congruent. So this is also 45 degrees. Remember that this is the vertex angle. So this is a 45. So I know that this is going to be 90 degrees here. Because if I add 45 and 45, that's 90. Minus 180 in a triangle, this is 90. And now guess what? Now I can solve D right here. Because if you notice here, this is 135. This is 90. And I got almost a circle going on here. I almost got a circle. Remember, there's 360 degrees in a circle. So I can add these two together and subtract from 360, and it's going to give me the measure of angle D. So 135 plus 90 is 225. That means these two angles together are 225 minus 360. That means that this angle over here is also 135 degrees, just kind of like this one over here. So D is 135. Let's keep going. I know that D is 135. Here, this is 95 degrees. Okay, let's not fall into the trap of saying, oh, Mr. C, this is 135 and this is 135, so this is automatically going to be 135 as well. Don't make that trap. Take the 2 seconds that it takes to figure it out. So, but you do recognize that you got like a circle going on here. So this is 95 degrees and this is 135. We can add these two together and subtract it from 360. That's 230 degrees. That means that you have 130 degrees over here. Now, they weren't asking us for that, but it's good to know that you have, good information. Now, we have, let's take a look here. What else can we find? Well, wait a minute. I know that this is 95 degrees. I know that these are a linear pair. So I can find this angle right here. So 135 minus 180 gives me 45 degrees. So I know that this is 45 degrees, right? And hold on a second. Yeah, these are a linear pair. So these should both equal to 180 together. So 135 minus 180 gives me 45. This is 95. Wait a minute. Isn't that a triangle? Sure. And how many degrees are in a triangle? 180. So I can add these two together and subtract from 180 to get B. So 45 plus 95 is equal to 140 minus 180 gives me what? 40 degrees. So I know that B is 40 degrees. So as I'm going along, little by little, I'm naturally solving these questions. And then finally, I got to find the measure of angle C. Now, first of all, what kind of shape is this right here? What kind of shape is this right here? Be careful. Make sure you count all the sides. Let me see here. That's 1, 2, 3, 4, 5, and 6. That's 6 right there. That's 6 right there. So really, you have 6 angles in here, 6 sides in here, which means you have 6 angles. And this little angle is like right here, but they're asking you for C, which is the one like right there, is the one right next to it. Well, in order for you to find that, you have to know, well, how many sides does a hexagon have? How many sides does a 6-sided polygon have? Well, remember, in the previous problem over here, we said that a hexagon had how many? 720 degrees. Or you could just do n minus 2, 6 minus 2, and do the formula. But I noticed, yeah, I remember I had a hexagon here. So this is also a hexagon, which means that I should have 720 degrees inside of it. I should have 720 degrees. Well, let's take a look here. This is 150. One angle there, it's 150. I can actually figure this one out here because these are a linear pair. So this in here, which they didn't tell me, right there, that should be 180 minus 45 because those are a linear pair. All right, look closely. These are a linear pair, so that should be 135 as well. Then I got 135, then I got 130. And what am I missing here? I'm missing, let's take a look here. I'm missing this angle here. How am I going to go around finding that angle there? But wait a minute. Maybe that looks a little bit too complicated as I'm doing it. But then I notice, what kind of triangle is this here? Oh, wait a minute. This is an isosceles triangle. I notice these, which means that these two base angles here are congruent. Okay, these two base angles here are congruent. Maybe that can help me out a little bit. Maybe that can help me out a little bit. What else do I got here? I know that this angle here is C. Excuse me, is 150 degrees. Okay. What else can I figure out? Is there any information that I can use here to figure this one out? This one's a toughie. This one's a toughie. This is B, which is 40. I got almost every angle inside this hexagon here. 1, 2, 3, 4, 5, and 6. Which means there's 720. If I had this angle here, that would help a lot in finding C. That would help me immensely. That'd be really easy to find. But I don't have it. I have two parallel lines here. Oh, wait a minute. No, they wouldn't do that. They wouldn't do that. No, that's not a, this is not a transversal because it's not touching all the way over here. In fact, let me get a clear sheet here so we can see what we're doing, what we're talking about. Okay, so yeah, so this is right here, this is 150. I'm looking for the measure of angle C, which is this angle right there. I got some more information here about these other angles. Let me fill this in. I know that this right here is 135, right? I know that D is also 135. I know this here is 130. And I know that this is 40. Okay, and they're asking me to find the measure of angle C. And this line right here is not a transversal because notice it doesn't skip there. However, this is a transversal, and this is a this is a transversal to these two parallel lines.